The most profound mysteries of the universe are about to be explained by the world's deepest thinkers. Ouch! In the most exquisite presentation
Daddy.
of all time.
Hey, would you cut that out?
Brace yourself
Daddy, I need you.
for the journey you've anticipated all your life.
I want milk.
Hold on for a minute.
Dimensions
I want a drink.
Unfurled!
Oh, no, not that! Oh!
I love you, Daddy.
The Zero Dimension!
I am a dot. I have 0 dimensions.
The zero dimension consists of one single point with nothing to measure.
The First Dimension!
I am a line. I have 1 dimension. Length.
A first-dimensional line consists of 2 endpoints and 1 line segment.
The Second Dimension!
I am a square. I have 2 dimensions. Length and width multiplied together equal my area, measured in square inches.
A second-dimensional square consists of 4 points, 4 lines, and 1 square.
The Third Dimension!
I am a cube. I have 3 dimensions. These 3 dimensions are length, width, height. Length, width, and height multiplied together equal my volume measured in cubic units.
A third-dimensional cube consists of 8 points, 12 lines, 6 squares, 1 cube.
What's that?
Don't ask me. In the world.
Some people say that time is the fourth dimension. Mr. Orbis is given an address with 3 coordinates for a very important meeting.
500 South, 6th Avenue, 7th floor. Whoa.
Will said the north-south coordinate is length.
Oh, yes.
East-west is width. And of course, up and down is height.
Well, how pretty.
A 4th coordinate is needed, or Mr. Orbis would miss his important meeting.
Ah.
They say that this 4th dimension, this extra coordinate, is time. He would miss his meeting if any one of these 4 coordinates was missing or incorrect. Let's try this again.
Aha! 4 o'clock. Whoa.
1 dimension, 2 dimensions, 3 dimensions, and 4 dimensions.
Mr. Orbis, come in.
The third dimension proudly presents Cubus and Orbis!
Thank you so much for taking your time for me, Professor Cubus.
Oh, not at all. Please, call me Mr. Cubus. Professor makes me sound so square. What brings you around?
Well, I was born pretty round. Never worked off the baby fat, I suppose.
Oh, no. Why are you here to see me?
Oh, yes. My kids have been asking me about dimensions, and so I made this cute little video to help them understand. I'd like to know what you think.
Ah, I simply love video presentations. Let's have a look.
Well, all right. So, what do you think?
Indeed, this is quite a decent depiction of traditional thought. So, you stop at the 4th dimension as space-time, do you?
Well, yes. Isn't that what the 4th dimension is, Dr. Cubus?
Please, Mr. Cubus, if you don't mind. Yes, space-time is one way of looking at a possible 4th dimension.
One way?
Oh, yes, indeed. Mr. Orbis, answer me this question. In which language do physicists speak?
Mostly Chinese, I guess.
I don't speak Chinese, but I can understand Chinese physicists when they speak a pure language.
Music?
No. Mathematics, of course. Math is the language of physics.
Oh, yeah.
Look here, we'll illustrate exponents. 3 to the power of 1 describes what?
The first dimension, a line. The 3 would be some unit of measurement to describe the length of a line.
Very good. For our metric units, let's use inches. And what is 3 to the power of 2?
3 squared, or square, that is 3 inches long by 3 inches wide, 9 square inches.
Yes, and 3 to the power of 3?
That's 3 cubed, or 27 cubic inches. Yes, I described all that in my video.
Absolutely you did. Now, what is 3 to the power of 4?
Oh, let's see here. 81, there's lined, squared, cubed, quadrocubed? Quattrocubado?
If exponents describe dimensions, then there is a 4th spatial dimension that is not time.
Quadrilineo. Righto! Is there a name for a 4D cuboid thingy?
There have been attempts to name it, like the hypercube and the tesseract, but we have no practical experience in that dimension, so it's hard to put a word to it. 3 to the power of 4 is the perfect word for it in the language of physics.
What does it describe? What are its measurements?
It follows the same pattern that you yourself illustrated in your little film. Each higher dimension adds another measurable feature to its matter. A 3D cube has
8 points, 12 lines, 6 squares, and 1 cube.
Yes, and if we follow the same pattern, a 4th-dimensional hypercube would have 16 points, 32 lines, 24 squares, 8 cubes, and 1 hypercube.
Holy triangles! Hey, some of these patterns are pretty easy. Would a 5th-dimensional pentacube have 32 points then?
Indeed it would, with 80 lines, 80 squares coincidentally, and 40 cubes. And how many hypercubes would it have?
Well, let's see. 2, 4, 6, 8, 10.
Yes, and these patterns continue through more complex dimensions, theoretically forever.
Mr. Cubus, what does a 4th-dimensional hypercube look like?
Nobody knows, really. But we do have models. Just as one can draw a recognizable representation of a 3D cube on a 2D paper surface, we can make some sort of distorted 3D model of a 4D hypercube.
What did you just say?
Let's start with a hexahedron net, or a cube net. In your video, your giggling lines put together a cube from a hexahedron net. Similarly, we can put 8 3D cubes together to create a hypercube net.
Oh!
Mr. Orbis?
Oh, sorry. I was just trying to picture a hypercube net.
Ah, as I was saying, just as the hexahedron net folds up on itself, the hypercube net does as well. Here, let me show you. We're going to put together a hypercube net. But first, in order to understand some of the abstractions that we'll experience, let's imagine two-dimensional beings attempting to fold up a cube net into a cube. A rather different perspective from your wonderful video.
Well, all right.
They know that these points will have to touch, uniting two lines to become one. So they'll have to distort a couple of squares, still understanding that they're squares, not parallelograms as they appear. These points and lines unite as well. Now these sets of points also have to touch, so we further distort our squares into thin trapezoids. Now what do they do with the seemingly extra square? It appears that our cube would be complete with the necessary 6 squares, of the same size mind you, 12 lines of equal length, and 8 dots. But since we are third-dimensional, we recognize that we're looking down on an open box. It needs a lid, so to speak, to close it into an actual 6-sided box. To second dimensioners, this last square appears to envelop the entire structure rather than closing it. Let's pretend our hypercube net is filled with water.
Oh, or Jello.
Alright, Jello. And on we go to our Jello hypercube net. These points will have to touch, joining two cubes by making two squares become one. The same process will happen with all the other cubes as well. Except the bottom cube. That one will be the hypercubical lid, so to speak, which will seemingly pass through the other cubes to close up the open 4D hypercube.
But wait! Those other 7 cubes are already solid, totally filled with Jello. How can that 8th solid cube occupy the same space as all the others?
That's precisely the grand abstraction that illustrates a beautiful mystery of the 4th dimension. Like the 6 squares that enclose our original cube of Jello, these 7 cubes only make up some kind of 3D perimeter of a 4D vessel that needs to be filled with whatever 4D material is. And this last cube keeps that 4D material in.
So 4D matter is nothing like the particles that make up our matter?
Not in the slightest. Our matter, if observed in the 4th dimension, is as unsubstantial as an image projected onto a wall is to us.
But there is no substance to an image on a wall.
Indeed, it seems to be so in our dimension. This may be obvious, but I have to point out that in our point-line square model of lower dimensions, there are fallacies. In reality, just how small is a dot? How narrow is an actual line? How thin is an authentic square?
Well, I suppose that they're all nothing.
So it may seem, Mr. Orbis, in our 3D point of view, but at varying degrees of so-called nothingness.
Varying degrees?
There is indeed substance there, intangible to us here.
Intangible substance?
Let us revisit the lower dimensions in a little video presentation of mine. Please excuse my video's horribly fake American accent. Watch and learn! Dimensional realities are far greater than lineland, flatland, and cubeland. Oh no, not that! Not again! Oh, bother.